Projectile motion. We are putting the first concept. Projectile motion is an example of two-dimensional motion, a horizontal and a vertical motion. Now, the idea comes here, how there are two motions here. If you throw a ball like this, there is a horizontal displacement and there is a vertical displacement. So when you throw a projectile, it travels in two dimensions. This is an example of a projectile motion. The object is traveling on a curve. Look at this screen. It's traveling upward and as well as horizontal. So when you launch a missile, when you throw a ball, this is an example of a projectile motion. There are two displacements, there are two displacements, there are two velocities. In a projectile motion, like a missile, for example, it travels forward and it travels upward also. This is a very famous game of its time, Angry Birds, and it travels in a curve, and this is a projectile motion. When you kick a football, it travels in a curved trajectory, and this is called a projectile motion. So we are putting the first concept like this. This is our first concept. You have to copy this screen. Done. Projectile motion is an example of two-dimensional motion. The two dimensions are horizontal and vertical motion. Projectile motion is treated as a separate topic, even though it's part of kinematics, but its question is always separate. And normally the questions are a bit tricky. Kinematics is mainly for sketches in our paper, and projectile is mainly for calculations. The question on projectile are very frequent now. In new papers, they are very frequent. Now, this is our first concept. In a projectile motion, there is a horizontal displacement and there is a vertical displacement. You have to copy this. Done. This is an example, and the football is a good example of that. Now, as usual, in every physics, there are some assumptions to standardize the formulas. So now give the heading, give the heading assumptions. The all-time famous assumption, which is always there, the air resistance is negligible. The value of G remains constant throughout the motion, and there is no sideways or spin motion. But the first assumption is very important. You have to copy this screen.
Okay.
Now we are putting our third concept. The second is obviously the air resistance is negligible, and the main parameters of a projectile motion are launch velocity and the launch angle. These are the two main assumptions. These are the two main parameters, that how, at what angle you launch the object, and at what angle and at what velocity. So when you launch something, you have to put some energy like velocity, and when you launch something at an angle, when you launch something at an angle, it is called launch angle. The velocity is a control, like cricket, like football. When you hit a ball, you set a target. Like in cricket, you want to throw the ball outside the boundary. So you have to manage the angle and you have to manage the velocity. So this is our third concept in this topic. You have to copy this screen.
Okay.
This is our third concept under the title of projectile. Ali, I think you have joined. If you have joined it, yes, Ali, sorry, Zen, if you have joined it. So we have started projectile motion today. We have started projectile
Yes, sir.
motion. And this is our title for today, projectile motion, as a part of quick revision. Necessarily, we can't do it as a regular topic, but projectile is a special topic. I think it was not in the June paper, if I'm right. If I'm right, projectile didn't come in your paper. If I'm right, projectile was there or
I
not?
think so, sir. I
Projectile
think कोई
was
छोटा सा सवाल आया था, एक छोटा सा पार्ट आया था. Maybe I'm not मुझे याद नहीं है.
okay. So projectile motion is an example of two-dimensional motion, a horizontal and a vertical motion. So please give a heading, projectile motion. Give a heading, projectile motion, and
Yes, sir. Give.
okay, good. And join us from this position. There are three important assumptions of a projectile. So give a heading, side heading, assumptions. And now copy these assumptions.
Yes, sir. Done.
So these are the three important assumptions of projectile. The first one is the main assumption, that air resistance is negligible in our projectile motion. We do not consider air resistance, even though air resistance is critical. Now, next concept is there are two parameters. So when you hit a ball, like in football, like in cricket, if you hit a ball and the ball goes up and the ball goes forward also, there are two parameters: at what angle you throw it and what velocity you throw it. So these are the 2 points: launch velocity and launch angle. Now you have to copy this concept.
Yes, sir. Copy.
Then you have to copy this diagram.
Sir, the angle theta is being made with the red line and the bottom um, yellow line, or is it being made with the blue curved line in the bottom?
No, sorry, I couldn't get Zen. What did you say? The yellow line is the dotted line.
Yes, sir, but जो theta बन रहा है, theta किन दो लाइनों के बीच में बन रहा है, red और yellow, right?
Theta cannot be with the curve. Remember,
जी
it's a
जी
math concept. It's a math concept that angle is always with a straight line.
जी जी बिल्कुल. I just wanted to clarify that. Maybe
तो वो
yes,
उसी
ठीक है.
का, अगर आप उसको देखोगे ना, तो it's touching the red arrow.
जी जी. Copied, sir.
Now this is our the concept here. Now the launch velocity can be resolved into horizontal and vertical components. Resolution is one of their favorite topics. Now, what is the idea here? That when you launch a velocity, when you throw a projectile like a missile, like a football, there are two components. One is horizontal and second is vertical. Why there are two components? Because a projectile has to go forward as well
Forward and upwards.
as to go upward. So this is the main concept now of projectile, the core concept. In a projectile motion, there are two components. One is the v cos theta, which will take you forward. Second is v sine theta, which will take you upward. So as you move forward, v sine theta gradually decreases until it becomes 0. At the highest point, only v cos theta alone survives. But when you go downward, the v sine theta again increases and it will reach the same starting value. This is how we show the plus minus. Now we have a concept: at the highest point, the vertical component of velocity is 0. Vertical component first decreases to 0 and then increases to the same value. If it's a level flight, then angle of launch is the same as angle of strike. But if the flight is not at the level, then the two velocities are not the same. In a projectile, we had a very important concept that throughout the vertical velocity, the gravitational constant is there. Air resistance is normally air resistance opposes the horizontal component. Now we assume there is no air resistance. So when you assume that there is no air resistance, then horizontal component of velocity will be constant, while the vertical component initially decreases and then it increases. Look at this screen. The horizontal component of velocity, this is horizontal component, it's not changing, but vertical component of velocity is increasing. This is the idea that vertical component changes. Now you have to copy this diagram.
So do I not just alter the last diagram I made, or do I make a new one?
You're talking about this one?
Yes. Yes, ये वाला नया बना देता हूँ.
Now you have to copy this diagram neatly. Neatly means make sure that V cos theta does not change in size.
Yeah.
This diagram is the main diagram, and obviously it's a November target. So topic to topic strength matters. And I had shared a plan. I hope, Ali, if you are following the plan. Then are you following the plan?
Yes sir, so आपने पहले अली कहा था, I'm not sure अगर मुझे कह
हाँ,
रहे थे
वो
किसी और
इन
को।
दिनों it's such a hectic ना, मतलब
जी
ये
जी जी
November
बिल्कुल।
session is very hectic. So people are asking queries, some people are double-minded, some triple-minded. So November session is always a hectic session. So, and it's a problem with me especially that names mix, and because from teaching a long time, then after I make a mistake.
जी जी
So
sir.
are you conducting the plan, because it's a
Yes
matter of
yes
do and die. Just a minute, please. Just a minute. Hold on.
जी, no problem sir, I am
Just
following the plan.
keep on copying it. Uh, you know, we have discussed the formula for the resultant velocity. There are two components of motion in projectile. So we have used Pythagoras theorem approach to find the resultant velocity. I have highlighted here Vx and Vy and the launch angle. This is the formula for the overall velocity. Now, selection of equation. This is a very tricky part. Selection of equation means that when you are dealing with a projectile motion, how you will decide which equation to be used in what condition. So please give this heading. Now, look at this situation. Now there is a vertical component, and there is a horizontal component. Remember that for vertical component, we can use all the equations of motion, but for horizontal, we can use only one equation. So this is for the case. Equations for vertical motion. These are our main equations to remember. Now you have to now please copy this equation, copy this screen. Let me know once you have copied it.
Yeah.
Okay, then let me know once you have copied it.
Just on the last line, sir. And done. Done, sir.
So repeat the concept with me that there are two dimensions in motion of a projectile. There are two dimensions of motion in a projectile, v sine theta and v cos theta. For v sine theta, you have the complete set of equations. Equations for vertical motion. This is the heading, and these are the equations. So remember to keep the heading, equations for vertical motion. Check it if you haven't given the heading, please give the heading again. Now,
Done, sir.
u is equal to initial value of v sine theta and v is equal to final value of v sine theta. This is, as I mentioned, that this is a very tricky part of this chapter. For the horizontal motion, there is no acceleration. In the horizontal motion, there is no acceleration. So one and the only equation is here, this one. You have to copy this screen.
Yeah.
Done, sir.
Now, contribution of launch angle. So you control the angle if you have a chance of playing throw ball, cricket, football, where you need to lift the ball from the surface. So when you launch a velocity, you need to maintain the angle. Otherwise, you can't reach the target you are looking for. This is an animation, and then I think you use headphone, right?
Yes, sir.
So you have to for just like a minute, you have to decrease the volume or mute it or
I
decrease it.
just mute myself.
Nee. The speaker sound is high of this animation.
Oh, अच्छा मैं वो कर लेता हूँ. For
कम
my
कर
own
दो.
ears, ठीक है.
Zero नहीं करना, because you need to hear that sound. लेकिन वो sound वो launch sound है ना, तो वो loud है. Are you done with the lowering the volume of your
Yes,
speaker?
yes, sir. I'm on half now. ठीक है.
Now, this is a very interesting angle work here. Different angles. Now, I think you can identify that by changing the angle, the main change, what is the main change? By changing the angle, the range changes. 15-degree range, 30-degree range, 45. If you look at 45-degree, the range, then you look at 60-degree, 75, 90 is going up forever. Now, my question is here that which angle is giving me the maximum range, horizontal range?
Sir, 45.
45-degree is giving me the maximum range. Good. Can you tell me, you take maths also, why 45-degree is giving me the maximum range?
Sir, I would suppose I think 90 का direct half है, so
नहीं, ये
we right?
this is not a maths based answer. This is like a fluck.
This is a tukka. Yes.
लेकिन you have to think again. You know maths, trigonometry.
I am drawing a blank, sir. Sorry.
Think again, use a calculator. And so what is the concept here? We are discussing that one thing is clear. One thing is clear that the maximum range is coming at an angle of 45-degree. The maximum range is coming at an angle of 45-degree. So maximum range is at 45-degree. Now our trigonometry says that as theta increases, V cos theta decreases and V sin theta increases. And when it is sin 45, the range is maximum. The answer is simply there that it's a trigonometry value. In trigonometry, sin 45 is equal to cos 45. So it means the contribution is the maximum. So give us side heading, contribution of launch angle. Copy this screen.
Teacher copied.
Done.
Maximum range is at 45-degree. And this is a pure mathematical reason which is now coming. You have to copy this screen.
Done.
Answer.
Now, half or incomplete projectile motion. This is going to be our next title. The diagram is there. This is called a half projectile. This is also a half projectile. So I have given two examples. One is the object is coming down, and second, it is going upward for half motion. This is called half or incomplete projectile. You have to copy this.
Done.
Now, we are going towards another difficult topic here, that in a projectile motion, when you throw something upward, there are three versions, there are three options. I'm first focusing on option A. We first focus on option A. You can look here, when you throw it horizontally, what happens? The ball goes forward. Initially, the vertical component of velocity is 0. The vertical component of velocity is 0. A is equal to plus G. The ball is coming down. So this is a downward motion. And you can look at the screen. There is an initial horizontal velocity. Now, this is case A. This is the case number A, and I move to case number B now. Here, the ball initially goes up, comes down, level of the cliff, and then further go down. So now here, look at this position. Both horizontal and vertical velocities are there. Because it's traveling upward as well as forward. You have to copy this screen.
Done.
Yes, then let me know once you have copied it.
Yes, मैंने कर लिया.
Good. Now, there are two cases. I'm focusing on case number B. Case number B, there is an upward motion and then there is a downward motion. So until the object is above the cliff level, displacement is plus. Below the cliff level, displacement becomes negative. We show it like this. Now, this is the screen. You have to copy this.
Yes, sir, copied.
Now, the point is here, then why PQR in case of PQR, look at the diagram. Why in case of PQR, the displacement is 0? Why in case of PQR, the displacement is 0? This is a very important question. And whenever you are copying anything, remember that when you come across these type of concepts, do not allow them to go unattended, because copying is always simple, but these concepts later become a challenge. In the vertical motion, look at the screen. If the ball goes up, here the ball is going upward. The ball goes up and then it comes down. So suppose it is then 5 meter up and it is 5 meter down. So at this point, I put a question mark. How much would be the displacement?
So
5
0.
meter went up, 5 meter went down.
Yes, distance though he covered 10 meters, but the displacement is 0.
Very good. So now look at this concept. What is the displacement? 0.
0.
Second
Yes.
important question, why the displacement is negative? Because
So
when
because it is going below the original position, minus three में चला गया.
below the starting level, it always becomes 0. Case number C, one of their favorite cases, that you throw a ball upward, and this is a half projectile upward motion. You have to copy this.
Sir, I had a question about the previous slide. Yeah, over here there's RS. Why is it minus G? It's going downward, so why is it minus?
But this is what we were discussing now, and we had a view that this is the level of the cliff. You started from here. So when you go below the level where you started, displacement is negative. Displacement as a vector becomes negative when you go below the starting point. So suppose this is my home and I start from here. It is 5 meter. I turn back, come back, it is again 5 meter, displacement will be plus. But when I cross this position and go back, now it will be minus 5 meter. Displacement becomes negative when you go
No,
beyond
not
the
G.
starting point.
G. Minus G, the acceleration.
But I cleared that also. Na? Now minus G because of the downward motion. Now again, if you come back in the same situation, for the upward motion, velocity is plus, but for the downward motion, velocity becomes negative. Why G is negative, even though velocity is increasing? But actually, the minus sign of velocity is coming there. Velocity is negative, acceleration is not negative. Velocity is negative, and it is giving you a negative G. This negative G is not retardation. It is, interestingly, acceleration, and interestingly, velocity is increasing. Even though velocity is increasing, the acceleration is negative. Why? Because the velocity as a vector is negative. This is another paradox in our A-level physics, which we have discussed in the start of the chapter.
Okay, sir, thank you.
So let's mark it here, because Now you have to copy, you have to update the same screen.
Yes, sir. Copied, updated.
Now, this is our case number C, one of their favorite cases. Now here, look at this case. Here, G is minus as a genuine case. Here, minus G means retardation. Now, you have to copy this screen. Let me know once you have copied it.
Yes, sir. Copied.
Done.
Now, in a half projectile, look at this screen. This is called a half projectile. In a half projectile, the velocity component resolves. And in the start of the motion, there is no vertical component. In the start of the motion, here at the zero position, the zero component, Vy is equal to 0. Now look at this aeroplane. It is throwing a projectile on a target, but the aeroplane is dropping the bomb before the target. Why? Because the bomb will go in a projectile motion. So we made our concept, and here the projectile motion is considered to be half projectile here in this diagram. Now, look at this question. A stone is thrown horizontally from the top of a cliff. Air resistance is negligible. What graph shows the variation with time of the vertical component of stone velocity? We have made a detailed discussion today, and remember that this is case A. This is case A, where the projectile is thrown horizontally. Now, these type of sketches, remember that you have to analyze each and every sketch, A, B, C, D, everyone. He's cleverly talking about only vertical component. Vertical component, when it is thrown from the top, vertical component initially is 0, and then it increases. Vertical component is initially 0 and then it increases. So please give a try to this question. I have shown the translation of every sketch.
Sir, is it D?
Vertical component, in vertical component, acceleration is constant, as mentioned today, that horizontal motion, 0 acceleration, vertical motion, constant acceleration equal to G. Now, then what's your suggested answer?
Sir, so we have student here. I think teaching basic.
Answer is D. In a projectile motion, acceleration is constant. Now, contribution of time. Give a new heading, contribution of time. Contribution of time. Now, I make my concept here. Time is never relative. It is always absolute. Now, what is the meaning of this concept? This is a very general concept, but it's very interesting. Some features of motion are resolvable. You can resolve displacement. You can resolve displacement. You can resolve velocity. You can resolve acceleration, but you cannot resolve time. So if a projectile is moving like this, there is a horizontal displacement and there is a vertical displacement. There is a horizontal displacement and there is a vertical displacement. there is a horizontal velocity and there is a vertical velocity. There is a horizontal acceleration, which is 0, and there is a vertical acceleration, which is g. But what about time? Does the time also resolve? Answer is no. Time cannot be resolved because time is not something which can separate over things, which cannot be separated over things. So it's less like a concept to understand. If a student is reading a book and a student is sleeping there, both of them are sharing the same time space. Time does not divide over quantities. So it is not a concept to remember. It's a concept to remember that time is something which cannot be divided over quantities. So you have to copy this screen.
Done.
Answer.
So time is never time. Time is not resolved. Time for vertical component is the time for horizontal component. Displacement, velocity, and acceleration all are resolved, but not time. So what's the benefit of this concept? If you find the time for vertical component, you can use it for horizontal. It means time does not follow a ratio method. So you have to copy this also.
Done.
Answer.
So we made this concept. So in every projectile motion, there are three factors which are resolvable. There are three factors which are resolvable. One is called velocity, one is called displacement, and one is called acceleration. But time is not resolvable. So time is a constant factor. Time doesn't follow a ratio. It means that you can't apply a ratio. So if you have, suppose one train takes 5 hours to reach somewhere. So if two trains go together to the same destination, they will share the same time. Time won't be doubled because time is always in a space to share. Now we are moving towards the end of this topic, effect of air resistance. Give this heading.
Yes, sir.
Done.
air resistance or viscous drag actually acts as an opposition force. It's always there. Air resistance or viscous drag opposes both the components of velocity. Both the components of velocity, it opposes both horizontal and vertical components. Now, what is the net effect? Time of flight is reduced, range reduces, maximum height reduces. You have to copy this screen now.
Um,
So,
Now, let's move towards the summary of this important topic. And these are the three important results of air resistance. You have to copy this summary now.
okay.
Now, we are done with this topic, and I'm doing a question to discuss for our working today. And I have shared this file, and if you can open it on your, this is the file. It is named projectile, and I think the word optimize it with it also. It's a sheet number 2 in that file. If you can open it, if you have a, if you are having a presently a parallel device, then look at the first question. A bomber flies with a constant velocity of 50 meters per second at a constant height of 1000 meters such that it will fly above a target on the ground. What is the horizontal distance of the bomber from the target that a bomb release from it will hit the target? I have shown you an animation today also. So now you have to read the question and make the data. First, read the question again. Now, hopefully you have read the question. Let's try to start this question now. And I have made a diagram here. It's a paper 2 style question, so I should be making a diagram. And I have made a diagram according to the question. So please copy this diagram along with the footnote. The time for vertical and horizontal displacement is the same.
So copy.
Now you have to start this. There are two motions. There are two dimensions in this motion. Now, this is a vertical motion. I have shown the positive G, and if you start this working, look at the working here that I have shown. Look at the motion that I have shown, that after some time, the component of horizontal velocity is still at 50, but vertical velocity appears, vertical component appears now. So update the same diagram. We need to find D. Update the same diagram.
Done.
Yes.
Now proceed forward. We have made the diagram and now we can start the working. Look at the vertical motion. For vertical motion, U is equal to 0. The vertical distance is there. The value of A is there. And when you do that, you can use the equation of motion to find the time to reach the ground. Remember that time for horizontal motion is the same as the time for vertical motion. Both the times are the same. So if you calculate time for horizontal motion, you will be getting actually the time for horizontal motion also. So now you have to copy this. First, I have calculated the time.
Yes, copied.
Then time for horizontal is the time for the vertical. So please start solving it.
So once again, I'll keep my backup calculator.
Okay.
Sir, will it be for 214?
214. Okay, let's see. Both the times are equal. So time is something which is in a line, which is in a sharing feature. So horizontal displacement is coming to be 714.
Not, sir, it's 715, like exactly.
Maybe a small number difference is there. That's fine. Because a bit rounding always occurs because students tell me these answers. So if this is the case, then it's fine.
Yes, sir.
Please look at the solution quickly, then.
Correct, sir.
Now look at the second question now, question number 9. An object is released from an aeroplane which is diving at an angle of 30. The previous case was is thrown horizontally of, it was a horizontal launch. Now this is from an aeroplane which is diving at an angle of 30 from the horizontal with a speed of 50. If the plane is at a height of 4,000 meters from the ground, when the object is released, find the velocity of the object when it hits the ground. So now read the question. Read the question. Let's model this question because it's a paper 2 question, so that will be better if we can model it like a diagram. It is a projectile. So now copy this screen and you have to solve it. I'm just coming. Please copy this screen. I have made the data. The U is 50 sine 30. A is equal to plus G, and you need to find S is equal to H 4000. You need to find V. Make it sure that V means vertical component of velocity. V means vertical component of velocity. Now help me to solve for V.
सर मैंने जो कैलकुलेट किया उसके 25.38 आ रहा है V का वैल्यू. So that's not wrong. मैंने यही तरीका इस्तेमाल किया. I'm making subject. I didn't rearrange it. I put the values and I made V the subject.
हाँ फिर सही है.
50 sine 30 squared is 625. V square minus 625 लिखा is equal to 19.62 because 9.81 से multiply कर देगा तो 19.62 आ जाता है. Then we take 625 on the other side, we add it. 644.62 is equal to V squared, so we square both sides और हमारा square root both sides 25.38 final answer.
Sir, I did it a little differently and I got like 284.
How did you do that?
I did not resolve anything. I just took U square as 50 square. But I'll lose marks if we have to resolve, right?
No, that's not a problem. But how did you? Actually, you take 50 as a resultant velocity, right?
Yeah, I took U as 50 square.
50 square and resultant velocity, and then
Yeah, so basically V square was 50 square plus 2 times 9.81 times 4,000.
initially the two components are there, and we need to find. We got the velocity of y, the velocity Vy as 280. So you have to make it a component figure again because this is the component here. You have to read the question. You have to read the question that what you have to find the velocity of the object when it hits the ground. He's asking for resultant velocity. Then can you check the answer? I'm getting 280.
Yes, मेरा गलत है. I've done some mistake in writing the value down. I'm just rechecking it. Yes. मैंने 2as की जगह I just did 2a. मैं s की value input किया. I लिखा था अगले step में, मैंने somehow गायब कर दी. Human mindset. I'm fixing it. मेरा आ रहा है 281.25 आ रहा है.
Now, technically, this is the vertical component of velocity. Now go for resolution step. Part 2. The time taken for the object to reach the ground. Time taken for the object to reach the ground. Time can be found from horizontal or vertical, any component. Time can be found from any component. So I make the database for time. I have the initial velocity vertical component, final velocity vertical component, formula for A and T. Now the data is in front of you, people. You have to solve it.
Sorry, Aaron, I was unmuted. Sir.
So now
जी ठीक है t की वैल्यू से
Yeah, I'm getting 26.
answer is coming 26.
yes, it's 26.
Now, this is a very famous MCQ. It has appeared many times. People now remember it. MCQs repetition occurs. Now, read the question number 9 on this sheet, and you have to answer this. Obviously, you should read all the options.
Is it A?
Now, look at this one. Which statement is true for the projectile when it is at the highest point? This is the highest point. The horizontal component of projectile acceleration is 0. Projectile acceleration for horizontal part is always 0. Horizontal component of velocity is 0. That's wrong. Horizontal velocity does not become 0. Kinetic energy, it does not 0 because it doesn't stop. Momentum is a product of mass and velocity. That's also not 0. Actually, the horizontal component of acceleration is not 0 at the highest point only. It is 0 at every point on the motion. So answer is A. Now we talk about question. This is also a tricky question, but this is displacement regarding. Read this question. An object is projected at an angle to the horizontal in a gravitational field and it follows a parabolic path. A parabolic path is like this. PQRST, these points are the positions of the object after successive equal time interval, T being the highest point reached. So once you draw a projectile, it is better to remember that if you draw a projectile and you show the horizontal and vertical displacements, if you draw a projectile and you draw the horizontal and vertical displacement at a different position, you can observe the vertical displacement is changing. Horizontal displacement does not change. This is a projectile motion. The horizontal displacement is the same, but vertical displacement is decreasing, and then it reaches at the maximum point, the vertical displacement is not changing anymore. Now, this is the motion of the part, this is the motion of the object. Now read the question. So the displacement PQ, QR, ST
So the answer will be D then.
have equal vertical component, equal increase at a constant rate. The displacement PQ, QR, ST, as the projectile is going upward, the displacement becomes decreasing until at the highest point, the displacement number is on the zero position. So it's a parabolic path. PQ, these points are the position of the object after successive equal time interval. T is the highest point reached. Now this is the diagram. So you can see the displacement is decreasing. The displacement is gradually decreasing. This is right, have equal horizontal component. That's a correct point. This is a correct point, that equal horizontal component increase at a constant rate. This is not possible. Decrease at a constant rate is also not, it decreases, but it doesn't decrease at a constant rate. Constant rate means by one number every time. So answer is C. Now look at question number 44. Read this question. In the absence of air resistance, a stone is thrown from P and follows a parabolic path in which the highest point reached is T. Read this question. He will try to trap you so you can mark a wrong answer.
Is it D? Because it's 0 at both P and T?
Now, the vertical component of acceleration, remember that vertical component of acceleration is G. Vertical component of acceleration is G, and G is the same. It can't be 0 anywhere. In the whole of the projectile motion, the value of acceleration is constant. The vertical component of acceleration is constant. It is the same at every point. It's G, small g. So the answer is D, last option. Then you are not answering somehow.
No, sir, I'm still very much here. I am noting down everything.
But that's right, you are here, but you're supposed to answer, not the class is ending now.
Sorry, I will answer again.
Another very famous question, very good practice question of its time from 93. It has appeared around 7 times in the paper. It's a very famous question and it gives you a very good concept of projectile. So let's take it the ending question for today. So please read it and try to solve it. You have 3 minutes. You have 3 minutes. I'm just coming. You have 3 minutes to solve it.
Answer.
I have made the data, and if you people have tried it, this question, please look at the possible working.
So I did the question. मैंने ऐसे किया था कि s is equal to u t plus 1/80 अप्लाई किया, u equal to 0, s is equal to 1.25 and a is equal to 9.81. निकालने के बाद टाइम की बारी 5 सेकंड्स आई थी. स्पीड इज इक्वल टू डिस्टेंस ओवर टाइम का फॉर्मूला अप्लाई करके I 10 over 0.505 कर लिया. 20.50 seconds और s is equal to 20 meter per second.
पहले Vx is equal to 20 और वो आ गया ना. पहले आप टाइम निकाल लो, टाइम रखकर वेलोसिटी निकालो और फिर उसको रखकर जो मेरे पास जो आ रहा है Vx is equal to 20, ऑप्शन आ रहा है डी. So let's keep it up to here, and we will inshallah continue this in our next class. Allah Hafiz.
Sure.